Hi, I'm Hideaki Joko from Radboud University. In this presentation, I would like to introduce our research, Conversational Entity Linking, Problem Definition, and Datasets. Entity linking is the task of recognizing entity mentions in text and identifying their corresponding entities in knowledge graph, such as Wikipedia. Entity linking is also beneficial to understand the user utterance. Look at the example. To understand the final user utterance, the system has to identify the restaurants which offer fettuccine alfredo. Also, restaurants which offer a lot of tomato menus should be excluded. By linking their mentions to the knowledge graph, where knowledge about restaurants exists, the system can provide better answer to users. In conversations, as we see in the previous slide, entity linking can be used for machine understanding of user utterances. Neural language models, such as BART, are not replacements for auxiliary information from knowledge graphs. Rather, the two are seen as complementary efforts. Now we understand entity linking is beneficial for understanding conversations. But the problem here is how to perform entity linking in conversations. One straightforward way is to use traditional entity linking models in conversations. But is it possible? What is the difference between documents and conversations? There are two major differences. The first one is that, unlike documents, conversations are informal. References to entities are made by their pronouns, such as my neighborhood or my guitar. Secondly, in conversations, all types of entities, including general concepts, can contribute to machine understanding of user utterances. For example, if the user says, I'm allergic to tomatoes, then the term tomatoes is an important concept that represents the property of the user. What does entity linking for conversations entail? To answer this research question, let's analyze entity linking annotations for existing conversational datasets. We studied approximately 130 conversational datasets targeting 3 conversational problems: question answering, task-oriented systems, and social chat. Selected datasets are multi-domain and multi-turn datasets that resemble real conversations. For example, obtained via wizard of Oz setting. Also, we selected relatively popular and well-received datasets. The selected datasets are Quack, Mulchwas, Wizard of Wikipedia, and TrackCast 2020. The selected datasets are annotated by crowd workers from Amazon Mechanical Turk. First, workers are asked to select entity mention pairs. Then, they are asked to identify concepts and named entities, and find helpful entities. Finally, they are asked to identify personal entities. First, workers are asked to select entity mention pairs. There are 2 steps. In the step 1, workers are required to read the dialogue. In the step 2, mention, in this example London, is given to workers, and they are asked to select the corresponding entity if any. Next, workers are required to identify concepts and named entities Here, instruction is select no entities, such as name of people, places, or organizations. The third step is to find helpful entities. Here, instruction says select the Wikipedia articles that help you to find an answer to the person's question. In the final step, workers are asked to identify personal entities. Personal entity mentions, in this case my guitar, are given to workers, and workers are asked to select the corresponding entity mentions in the conversation history. The options shown in mTorque are generated using existing entity linking tools TagMe, What, and Rel. TagMe is one of the most popular entity linking tools. What is the redesigned and improved version of TagMe. Rel is an open source entity linking tool based on state-of-the-art NLP research. They are employed in two ways, TORP method and history method. To generate a candidate for personal entity mentions, such as my guitar, we used pattern matching approach. The pattern we used are starting with my, followed by adjectives, noun, or numbers. All of the annotations are available to the community to further research in this area. Do personal entities and concepts actually play an important role in conversations? The answer is yes. The personal entities are mainly found in social chat, and 33% of dialogues in social chat contain personal entities. Also, 57% of entities marked as helpful by workers or concepts. Based on these results, personal entity and concepts are important in conversations. The second finding is about effectiveness of traditional entity linking methods. The table shows the entity linking results for our annotations. T and H represent turn and history method, which we have discussed before. The results show that the traditional entity linking methods are suboptimal for conversation. Finally, let's talk about personal entity. Does a simple extension of traditional entity linking work for personal entities? To answer this question, we developed a simple model for linking personal entities. This model contains two steps. In the first step, the model calculates the cosine similarity of the embeddings between the references of personal entity and all entities in the dialogue history. In the second step, the model compares these similarities and selects the entity which has the highest similarity score. The table is about personal entity linking results. The left block shows the original entity linking models, and right block shows the extended entity linking models where personal entities are also annotated. Even if you annotate the personal entities with the simple extension method, that does not improve the performance so much. The results show the simple extension of the traditional approach is not enough. Conclusions. Personal entities and concepts are important in conversations. Traditional entity linking tools are suboptimal for conversations. A methodological departure is required for conversational entity linking, especially for personal entities. Our annotations, we named it as ConEL dataset, are available in the project GitHub repository. So please have a look. Thank you.